So just like we've been trying to do in class, I've taken the liberty of making a position time graph, and then another position time graph, another position time graph, and then a velocity time graph, another velocity time graph, and then something that you're filling by yourselves. But what this ends up being is, I hope it will be good practice, and I really hope that you'll take a look at this and then push pause. And in a couple of seconds, I'll wait. We'll go over it, and then the next one you'll push pause, and then we'll go over it, and then the next one do the same thing. So right now, push pause. And hopefully in that time, you've done this. So let's take a look. Remember that position versus time, the slope will always be a velocity. So if we've got a constant slope here, it's a constant velocity. And the fact that the slope is positive means you're moving in the positive direction. So your constant velocity is positive. The second part, you've got no slope. So you've got no velocity, which means you're at rest. The third is a constant acceleration, and we're opening up, so it's a positive slope, positive acceleration, and positive velocity. So you are actually speeding up. 4, you are at rest. 5, you are turned around and going negative velocity and negative acceleration. So we are sloping down in our parabola, or going in the negative direction for velocity. 6, constant velocity, which is 0. So let's call it what it was. I screwed up. 6 should be rest. And 7, constant positive velocity. Now, pause it and work on it. And number 1 is going to be constant positive velocity. 2 would be at rest. 3 is going to be constant negative velocity. 4 again, rest. 5, constant positive velocity. 6, constant negative velocity. And 7, rest. Now we're at this complicated one. First one, position, rest. Sorry. Pause it. Now you can unpause it, and 1 is rest. 2, constant negative velocity, because we got a straight line with a negative slope. 3, we're going to be accelerating. Positive acceleration, and we're also going forward. Positive velocity. 4, rest. 5, constant negative velocity. Again, negative slope. 6, rest. And now we move on to our velocity graphs. You can go ahead and pause here. And we'll go ahead and check your answers. So 1 is going to be at rest, because again, we're dealing with velocity. And velocity of 0, you're at rest. 2, constant positive velocity. 3, you're at rest again. 4, you're at constant negative velocity. 5, you're at rest. And 6, constant positive velocity. Moving on to the next one. Pause it here. Work on these. So 1, we're at rest. 2, constant positive velocity. 3, I'm sorry, not constant positive velocity. I screwed up. This is a velocity time graph. So what we're dealing with is something that is increasing in velocity. And our word for that's acceleration. So you are having a positive acceleration, and you are moving in the positive direction. Remember, anything up here is positive direction. So you're having positive acceleration, positive velocity, which actually means you're speeding up. Then you hit here, and you come back. So now in the third one, you've got a positive velocity, because you're still up here, but you have a negative acceleration. which means you are slowing down. You continue. At 4, you have stopped, and you are changing direction. And then at 5, you've got negative velocity because now you're down here, which means you're going the other way. And you are negatively accelerating. When these two signs are the same, you're speeding up. 6, you have a negative velocity because you're still down here in velocity land, but you have a positive acceleration. You've got a positive slope on your velocity time graph. So now that these are opposite, just like number 3, you are slowing down. 7, you stop, because that's your velocity right there, 0. 8, you are positively accelerating, and you are also positive velocity because you're back up here and you're changing velocity. And if you really just want to think about this another way, you started at 0, you're going faster than 0, so you are speeding up. As opposed to here where you started away from 0 and got towards 0, you started fast and went slow. So that's why in 6 you were slowing down. 9, constant positive velocity, because between here and here you're not changing your speed. And then 10, you are at rest or stopped. This last piece, this is sort of what the honors class does. And what I'm going to do is I'm going to break it up into the different time frames that we look at. And if you look, I'm just taking this segment and breaking it from this segment and breaking it from this segment, breaking it from this segment, breaking it from this segment, breaking it from this segment. So I'm just trying to draw these lines so I more or less can end up with similar time points. And this, as I said, you really aren't going to be responsible for this, but I want you to be exposed to it. So for our first position time graph, we've got a constant change in position over time. And we call that a constant velocity. So our velocity is going to be constantly positive, and then we come to a rest. So positive velocity, then we rest. So when we rest, we go down to 0 velocity. Maybe I should do this in a different color. Let's go to red. So we'll start constant velocity, then we go to rest. Then our position changes with a negative velocity, and it seems to be a little bit slower because the slope here is big, the slope here is much smaller. So we're going to go here and take a slower negative velocity because, again, we're going in the negative direction. Here we're going in the positive direction. This is negative direction, negative velocity. Then we stop again. And this is where this next piece is where things get a little finicky. This is an acceleration. Right here, we're dealing with an acceleration, and it's a positive acceleration because we're sloped up. And what that translates into in a velocity time graph, if you remember, is a diagonal line, just like that. Positive acceleration and positive velocity, because once again, we're dealing with a positive, we're moving in the positive direction. Then we stop. Rest. And then we have a negative velocity because we're moving in the negative direction. So now we come here, and it's a really, really sharp one. So the slope is big, which means the velocity is big. It's just negatively big. So this is what it would look like to make a velocity time graph from a position time graph. I hope this helped. I'll try and come up with another video also, but this is a pretty good start. Again, this is not something you're going to be held responsible for, but I'm happy that you stuck around to actually watch it. Okie dokie.